Everything in life is made out of matter. Matter is anything that occupies space and has mass. So it has some weight to it and it occupies space. It can either be compounds, molecules, mixtures, or atoms. Atoms are the basic units that make up everything we see in life. So let's find out what these different things mean. Starting with the atom. The atom is a submicroscopic substance. So that means that it's even something that a microscope isn't able to find. It's very, very small, so small that one cannot even see it with your bare eyes. So you need special equipment to even be able to visualize an atom. A microscope isn't enough. So the atom is the basic unit and it is composed of three main components. It is made up of, first of all, the proton. And the proton is what we see at the center of the atom. So at the center of the atom, we call this center of the atom the nucleus. Okay. And so the proton is the positively charged particle found in the nucleus of the atom. And then also in the nucleus of the atom, which we said was the center of the atom, we find neutral substances. So these neutral substances are called neutrons. And together with the protons and the neutrons combine together to form the nucleus. This is where most of the weight, most of the heaviness of the atom, this is where it's all found. And then circulating around the nucleus, we see this tiny particle. It's even smaller than the proton and the neutron. This tiny particle is called the electrons, and electrons carry a negative charge. So protons carry a positive charge, electrons carry a negative charge, and the electrons are smaller than the protons, but these electrons are found outside of the nucleus, just circulating around the nucleus in layers called shells. So this is the first shell. This is the first shell. And then this is the second shell, and then there can be multiple more shells. Okay, so this is the basic structure of the atom, and just so we remember, the atom is the submicroscopic submicroscopic um, substance that makes up everything that we see in matter. So it's kind of the basic building block of matter. So we have different types of atoms, and we classify the different types of atoms based on the number of protons that are present. So if a substance has one proton, then we will call that element or that substance hydrogen. If it has two protons, helium, three protons, lithium, and so on and so forth. We organize the different types of atoms in a table called the periodic table. As you can see, there's a lot of different atoms that are present and they make up lots of different elements. So we organize all these different substances or different atoms in a table called the periodic table. As you progress in your chemistry understanding, you begin understanding what goes into the periodic table and how to identify different types of atoms, elements. So I've been speaking on elements. Let's talk about elements. So elements are substances that are made up of only one type of atom. So substances made up of one type of atom. I've brought in an example over here. So the example I have pictured here, this silver thing is called sodium. And sodium is given the name Na. Because the thing with the periodic table is that we have these different types of atoms and they're all a mouthful. So we have given these different atoms symbols. So sodium symbol is Na and it is found in the periodic table in this location. So that means that it has 11 protons. But we call it sodium because it has 11 protons, but this sodium is actually an element because every single substance that is inside this little silver block, all those substances are actually just sodium atoms. You see in this structure over here, we just see sodium, 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 sodium everywhere. And it's floating around in a cloud of electrons. But every single atom that you identify in this substance is called sodium because they all the different atoms in this substance all have 11 protons. So they're all classed as, sodium atoms. So it's an element because it's a substance that's only made up of one type of atom. Then what happens when the atom doesn't want to exist on its own? It's actually a very rare occurrence just to see an atom on its own. It's very rare to see an atom floating around on its own. Most times, atoms will combine with other atoms through things called bonds to make molecules and compounds. So, for example, we see sulfur here. Sulfur is a type of atom, and we will see it in the periodic table as well. If sulfur, a type of atom, wants to combine with other sulfurs, typically in nature, it will form a sulfur molecule made up of 8 different sulfurs, making up a ring. So, we have all these different sulfurs bonding with one another to make a sulfur 8 ring. It's sulfur 8 because this ring has 8 different sulfurs. And so because it's not just an atom on its own, it's bonded with other atoms, we would call this a molecule. And so we can say a molecule is made when atoms form bonds with other atoms. So atoms bonding with other atoms, that's called a molecule. Now there is a specific type of molecule that is formed called a compound. So a compound, number one, is a type of molecule. But what's unique about this molecule is that the bonds form between different types of atoms. So I've brought in the example of water molecules. We drink water every day. Our body is primarily water. Everything that's living usually has water in it. So water is given the formula H2O. That means that it has two hydrogen atoms bonding with one oxygen atom. So when it has different types of atoms bonding with each other, then we would usually call it a compound. So water is a molecule because of course it has atoms bonding with each other, but more specifically, it is a compound because it's made up of different types of atoms. This is actually very interesting. So I do want to go back to the example of sulfur 8. You could also say that sulfur 8 is technically an element, right? Because it's a substance made up of only sulfur atoms. So it's technically an element, but more accurately, we could just call it an elemental molecule. So it's an element and it's a molecule because there are bonds existing between the different atoms, yes. So it's a molecule, but it is made up of only one type of atom, sulfur. So it's an element. That's really interesting. So we have the compounds, which are a unique type of molecule made up of different atoms, and then we have the molecules, which in general are formed from atoms making different bonds with each other. The picture I have shown you is the bonds in the pictures here, sorry. The bonds share electrons. You see the electrons that are in the cloud are surrounding the nucleus. So at the center of the sulfur, you have the nucleus, and then surrounding the nucleus is the electrons, and the electrons are usually represented as dots or as X's. But in this picture in sulfur 8, the electrons are dots. So we see that the electrons are being shared between one another. And so we call that type of bond a covalent bond. And same thing goes here. If I was to show you a picture here, let me draw the water molecule in a different way. So I can have oxygen, and then that has bonds with hydrogen and hydrogen. This line over here represents two different electrons that I'm going to draw as an X. Because oxygen is sharing electrons with hydrogen, same thing here, oxygen is sharing electrons with hydrogens. They are both sharing the same electrons together. We can also call this a covalent bond. So in the pictures here, we have two different instances of covalent bonds in S8 and covalent bonds in H2O, which is water. But there are other types of bonds. Let's look at them. So we have different types of chemical bonds. First one is ionic bonds. So the first one, in this case, we have a metal, sodium, and a non-metal, chlorine. In this case, the electron isn't being shared. The electron is basically traveling all the way from the metal to the non-metal. So because of that, the metal becomes positively charged and the non-metal becomes negatively charged. Positive usually attracts negative, so they have a connection which is called an electrostatic connection. Electrostatic connection. And essentially, this is a connection where a positively charged substance attracts a negatively charged substance. In this case of sodium chloride, only one electron is traveling. But you see, here's another example in magnesium oxide. Magnesium is giving two of its electrons to oxygen, so it's becoming positively charged by 2 plus, and the oxygen is becoming negatively charged twice fold. So these two different charges attract electrostatically and make an ionic bond. And then we also have the covalent bond. So covalent bonds take place when the electrons aren't traveling directly from one, you know, substance to the other. Instead, they decide that they want to share their electrons together. Okay, so usually you can see oxygen and oxygen, they can form a compound, they can form a molecule together by sharing two pairs of electrons. So covalent bond is sharing, while ionic bond is like a complete transference of electrons from one atom to the next. Then there's also hydrogen bonds that take place in cases where there's like a high electrostatic difference. So for example, oxygen likes electrons more than hydrogen. So all the electrons in the covalent bond would tend to kind of want to be closer to oxygen. And the same thing goes for this other molecule. All the electrons will want to be closer to oxygen. It's not that the oxygen is completely taking the electrons away, it's just shifting the electrons closer to itself. So oxygen becomes partially negative, so there's a partial negative charge, and then hydrogen becomes partially positive. But keep in mind, this is not ionic because the electrons aren't going completely away from hydrogen. The electrons are still being shared between hydrogen and oxygen. It's just that the electrons tend to spend more time closer to oxygen because oxygen is more electronegative. It likes the electrons more. Okay, and so then you see that there is a hydrogen bond taking place between the partially negative oxygen and the partially positive hydrogen of another molecule. And then you have the metallic bonds, which typically take place in metals. Metals tend to be found on the left side of the periodic table. So usually what would happen is that the metals don't like electrons. Metals like to give away their electrons. So in an element made up of just one type of metal like copper or sodium, as we saw in the previous slide, you can see that copper just spontaneously donates its electrons to the space around it, and all the coppers do that. So all the electrons end up floating around in an electron cloud. The electrons are negatively charged, and then the copper that donated the electron becomes positively charged, so it's called a copper ion. So it's a metal ion that is positively charged. Positively charged. And so what we see is that the positively charged ions adhere to the electron cloud. And so it's the electron cloud attracting the ions that keep the metal together. This is called a metallic bond. And then you also see mixtures. Mixtures are what occur when there is no chemical bond formation. So there is no chemical bond being formed. So you see here that we have one substance that is pink another substance that is green, but you never see the hybrid of a pink substance and a green substance. If it was to be a compound or a molecule, you would see that there is some type of bond between the pink substance and the green substance. But because they're completely separated from each other, there is no mixture, sorry, there is no like bonding. We would just say that they're a mixture because they're close to each other, but they're not bonded with each other. There's no bond between the different substances. This is what happens when you have a mixture. You can either have a heterogeneous mixture or a homogeneous mixture. A heterogeneous mixture is a mixture that is not thoroughly mixed. Okay, that's a bit weird to say, but that's basically saying that there is no uniformity in the mixture. So heterogeneous means no uniformity. No uniformity. It's not properly mixed. These two things are close to each other, but there's not like a complete mixture taking place. The reason why is because if I was to sample from maybe this part of the mixture, you're going to see it's only pink substance I see. If I sample from this section, you're going to see that you have a little bit of pink, some green. If I sample from over here, you're going to see it's only green that you're seeing. So it's not an even composition all throughout. There are some parts that have more of one mixture compared to the other, some parts that have maybe equal composition, some parts that have more of molecule or more of substance too. So it's not a complete mixture. Then you also have the homogeneous mixture. This is also made up of two or more different types of substances that are not bonded with each other, but it's a very uniform. So homogeneous means uniform. It's very uniform because if I sample from here, I have the same composition as if I sample from here. Sampling from here, I have half red, half green. If I sample from here, I have half pinkish red, half green. So it's an even composition all throughout. Here are some examples of heterogeneous mixtures. You have cereal. You see in the cereal, there are places where the cereal flakes clump together more, and then there's places where there is less cereal, more milk. So of course, it's a heterogeneous mixture. Ice and soda. The ice tends to go towards the top of the soda. So if I sample from the top of the mixture, you're going to see that there is more ice than soda. As I go towards the bottom of the ice soda mixture, it's going to be primarily soda, right? These are examples. And then there's soil. In the soil, there's places where maybe you see some plants, places where you see some, soil, places where there's rock, places where there's no rock. So of course, it is a heterogeneous mixture. And even blood. In the blood, you have blood cells. So in the blood, there's places where you see more red blood cells, places where you see more white blood cells, places where you see more water, more plasma. So it's not very uniform. But then there's cases where you see, a homogeneous mixture, which is very, very mixed together. Steel, for example, is an alloy where two different metals, or sorry, two different substances, which tend to be most times iron and carbon, are, yes, where they mix together very, very thoroughly, that if I sample any part of the steel, you're going to see even compositions of iron and carbon most times. Then, even in the case of vodka, which is alcohol, when you pour alcohol into a glass, it's very hard for you to see, places where there's, in fact, it's very hard to distinguish between the ethanol, which is the alcoholic substance, and the water. They're just so mixed together that you can't separate it. While heterogeneous mixtures is easy for you to separate, homogeneous mixtures is usually virtually impossible to separate unless you adopt some more more involved methods of separation like distillation or things like that. In summary, we have elements which are made up of just one type of substance. You can have elements like argon, which is a noble gas. It's just existing in a monoatomic space. So monoatomic means just one type of atom floating around, argon argon on its own, argon on its own, is just floating on its own. And then you also have elements that are made up of molecules, like oxygen having a covalent bond with oxygen. And this is diatomic. So two different types of two atoms, sorry, bonding together. But it's still an element because it's made up of the same type of substance. Then you have compounds, which are made up of different types of atoms. Here we have carbon dioxide, where it's just carbon bonding with oxygen, so two different types of atoms. It could be even three atoms, four atoms. It can go, the sky is the limit basically. And then you have mixtures where you have different types of substances that are coexisting with each other but are not bonded with each other. For example, you can have some argon and then oxygen, nitrogen, carbon dioxide. These are all things that are found in air, but they are not mixed together. They're not mixed together. It's just more of a homogeneous mixture, because it's very, if you look at air, you can't really tell that there's different, you know, there's different areas. It's just a very, very, very well mixed, together transparent thing called air. So that's it. We just discussed elements, compounds, mixtures. I added a little bit on the different ways that bonds can take place. It is worth noting that molecules are usually made up of substances that are covalently bonded with each other, while compounds can usually contain things that are like ionic bonded or covalent bonded, but compounds do have to contain different types of atoms. All right.